We're talking about the basics of probability theory. So an experiment is any observation of a random experience or incident. The outcomes are the different possible results of the experiment. The sample space will be the set of all possible outcomes for an experiment. An example of an experiment is observing the results of flipping a single coin. And head and tail are the possible outcomes for that example of an experiment. The sample space is the set head, comma, tail. So let's look at our first example. So determine a sample space for each experiment. So the first one is we select an iPhone from a production line and determine whether it is defective. So for example 1, part A, we want to find that sample space. So that's, remember, the possible outcomes. So if we're selecting an iPhone from a production line and determine whether it is defective, we are going to find two possibilities. Our sample space will be defective or non-defective. All right, let's look at part B. So 3 children are born to a family, and we note the birth order with respect to gender. Well, if we're having 3 possibilities, we can do this a couple of ways. We can either think about it in our mind, or we can actually draw out using something we've already learned about, and that's a tree diagram. So if we have 3 children are born to a family, we note the birth order with respect to gender. So again, let's hit begin. And we're having 3 children. We're going to start out with the possibilities. With respect to gender, we have a boy or a girl. And then the second child would possibly be a boy or a girl. And the third child would be a boy or a girl. So we can use things we've already learned to figure things out. So we'll do the second child, and then we'll do the third child. So our possibilities here are going to be if we had a boy, and a boy. If we have a boy, and a girl. If we have a boy, a girl, and a boy. If we have a boy, a girl, and a girl. If we have a girl, a boy, and a boy. A girl, a boy, and a girl. A girl, girl, boy. And a girl, girl, girl. So these are our sample spaces. So we have 8 of them, but it's in birth order, so those are the possibilities that we would have. All right, let's go look at part C. We select 1 card from a standard 52 card deck, and then without returning the card to the deck, we select a second card. We will assume the order in which we select the cards is important. So in this case, we're looking at how many ways. We're still finding the sample spaces, and they're all looking slightly different. Here we have 2. Here we had 8. This one we're going to use our fundamental counting principle that we know. This is without replacement is big to know. So if we pick the first card out of the 52, we know that we have 52 ways we can draw that. For the second card, it's 1 less than the deck because we've already pulled it. So this will have 51 choices left. When we multiply that out, we'll have 2,652 ways for us to draw in our sample space. as far as drawing the card. All right, let's go look at part D. We roll 2 dice and observe the pair of numbers showing up on the top faces, so on the ones that are on the top of the die. We note that 1, 3 is different from 3, 1 because this would be the first dice, this is the second dice, first and second. So we're looking at how many ways then are we going to make this happen. Well, as we roll 2 die, and they're separate, they're not like one deck. So if we roll the first die, then we're going to have a possible of 6 different numbers. If we roll the second die, we also have 6 different numbers it could be, 1 through 6. When we multiply that, we are going to do 36 ways, or be able to get. And this is the sample space for rolling the 2 dice. Now you can use this when you're doing your homework. If you notice, they're all within the curly brackets. We're looking at counting. This would be what the entire sample space would look like. So I want you to notice that here you've got 1, 1, 1, 2, and it goes so forth. The ones that don't kind of like repeat, where we talked about 1, 3 is different than 3, 1. So we have 1, 2, and we have 2, 1. Those are different. But when you get both as a 2, as a 3, as a 1, a 4, a 5, or 6, if you get the same number, those you're not going to see twice. They're only going to happen one time in there. And you can also start to notice some patterns here, that here they both end up adding to 2 or 3. Here they're both equal to 4. When we add them, here it'll be 5. This will be 6. This one, each set adds up to 7, and it goes forth. So that'll come in handy when you're doing the homework. All right, let's go look at example 2. So for example 2, we want to describe the events as subsets. So we're going to write each event as a subset of the sample space. So a head occurs when we flip a single coin. So we want to describe that. So this would be example 2. For part A, if we roll a head or flip a head on a coin, then that's what our sample space would look like. For part B, it says 2 girls and 1 boy are born into a family. Now, they haven't told us the order, they're just telling us we will have 2 girls and a boy. So in that case, we're going to have boy, girl, 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 boy, girl, and girl, girl, boy will be our possibilities. There are 3 ways that we could have 2 girls and 1 boy. All right, part C says a total of 5 occurs when we roll a pair of dice. So I talked about that. So that means we're adding. So here we get 4 plus 1 is 5, 3 plus 2 is 5, 2 plus 3 is 5, and 1 plus 4 is 5. So that diagonal row that you see there is where you're looking at the possibilities. So we'll write that as a sample space. So we're going to have 1, 4, and 2, 3, 3, 2, and 4, 1. Now, if you didn't have the handout looking there, you just need to think about the dice that add up to be 5. So you can't use the 5 because you've got to have 2 of them, so 5 would be too big. You can't use the 6 because the 6 is more than 5. So you would have to use the numbers below 5. So if we start with 1, we'd need to add 4 to get to 5. And you can flip it around because you get 1 on one die, 4 on the other, or 4 on this die, 1 on that die. And then with the 2 and the 3, if we have a 2, we'd need a 3. And if we rolled a 3, we would get a 2. So if you don't have the list, you can figure that out just by thinking about how that comes about. All right, so let's go to example. We're going to talk about example 3 here in a second after we look at our handout a little bit longer. So we have intuitive meaning of probability. So we're looking at probabilities. So impossible would be there's a 0.0 chance of it happening. A certain possibility is a 1.0 chance of it happening. If we've got a 50-50 chance, it's right there in the middle. Between 0.0 and 0.5, you've got not likely to occur, and if it's above 0.5 to 1.0, it's likely to occur. So when we're looking at probability of an outcome in a sample space, it's between 0 and 1 inclusive. Inclusive means it includes 0, it includes 1. P of E is the probability of an event E. So this is the event, so the probability of this event, and it's defined as the sum of the probabilities of the outcomes that make up that event of E. P, F, given E, is the conditional probability of F given, that's what the line means, given that E. So it's the probability of event F given that event E has already occurred. So the probability of the F event after E has already occurred. So basically it means that you know something else has already happened. So we are flipping 3 fair coins. What is the probability of each outcome in this sample space? How many times does flipping 2 tails and 1 head occur? And how many times does flipping a head and a tail, a tail, and a head occur? So we're flipping the coin. So this will be example 3. So we're going to draw another tree diagram. So we're beginning. And we're going to flip it. We know it's going to be a head or a tail. Doesn't matter if you put heads on the top and tail on the bottom. Doesn't matter. And then we're going to flip another coin and tail and a head. And this one will get a tail and a head. And then the third coin will get a tail and a head, and a tail and a head, and a tail and a head, and a tail and a head. All right. So what are the possibilities? Well, up here we have tail, tail, tail. And I know in the previous sections I did the heads on top, but I'm just showing you it doesn't matter which way you go. Tail, tail, head. Tail, head, tail. Tail, head, head. Head, tail, tail. Head, tail, head. Head, head, tail. Whoops. Head, head, tail. And head, head, head. All right, so our first question was, what is the probability of each outcome in the sample space? Well, how many do we have? We have 1, 2, 3, 4, 5, 6, 7, 8. So for part A, the probability of each outcome, because they're all unique outcomes, will be 1 out of our total of 8. So that's, again, what's the probability of each outcome? What's the likelihood that each of these will occur? 1 out of the total of 8 that we have. All right, part B, it's asking how many times does flipping 2 tails and then 1 head? So we're looking for 2 tails, 1 head occur. Well, if we're looking, that would be 2 tails, so tail, tail, head. When does that occur? Well, the only time that happens is this one right here, where we have 2 tails and then 1 head. So this would be equal to 1 out of 8. And then for part C, it asks how many times does flipping a head, a tail, and a head occur? So we're looking at a head, a tail, and a head. So when we look at that, we look down our list, and a head, tail, head only occurs right there. So that, again, is going to be 1 out of 8. All right, so let's look at a little bit of knowledge here. The outcomes are conditional on the results of the previous flipped coins, and that each event is the number of outcomes in an event out of the total sample space. So when we're looking at these are each event. Out of the total sample space, there are 8. So 1 event out of 8. All right, so example 4, we're determining the probability of each event. So a family with 3 children have exactly 2 girls. So let's go do example 4. And we're looking at part A. And for the event, we're looking at they have exactly 2 girls, but they have 3 children. So we could have 2 girls and then a boy. We could have a girl, a boy, and a girl. Or we could have the boy and then 2 girls. So if we're looking at that, what was our sample space when we did the children? So they had 3 children, and what was our sample space? We had 8 possibilities, right? 1, 2, 3, 4, 5, 6, 7, 8 possibilities. So we have figured out that there are 3 in our event. So if we want to look at the probability of E, it's equal to the number in the event over the number in the sample space. So in our event, we have 3 possibilities. In the sample space, there's a total of 8, which we've drawn out previously, so we're not going to draw it again. This would get us a 0.375. You can put the 0 in front if you want to. If we change that to a percent, we're going to move it over 2 places to the right, so it'll be 37.5%. So the probability of getting out of 3 children exactly 2 girls is 37.5% is the probability. All right, let's look at part B. So part B says a total of 4 shows when I roll 2 fair dice. So a total of 4. So we're going to go back over to here. And how many possibilities did we have for 4? Well, 3 plus 1 is 4, 2 plus 2, and 1 plus 3. So we're looking at our event is equal to 1, 3, 2, 2, and 3, 1. Again, we're looking at 2 dice that have to add to be 4. So the only way we can get 4 is if we add 1 plus 3 or 2 plus 2, and of course 3 plus 1. So if we look at the probability of the event, we have 1, 2, 3 events, and how many total did we have? We figured out before if we have those 2 dice, we have 36 ways. And this shows all the possible 36 events that can happen. So out of 36, we can reduce that down to 1 over 12, or you can take it from 3 over 36 into a decimal, which gets you 0.083. Move our decimal place over 2 places, and we end up with 8.3%. All right, let's look at part C. Part C says a total of 15 shows when I roll 2 fair dice. Well, if I have 2 dice, the 2 dice both have a possibility. The largest one is 6, right? So 6 plus 6 is 12. I can only get a total of up to 12 if I roll 2 6s. So what is the total of 15 showing when you roll 2 dice? 2 fair dice. And they do talk about fair to make sure it's not a trick dice. Then that means we can't get any of those. It's never going to equal 15. Our probability of the event would be 0 over 36, which would be 0. So that's definitely not going to occur. That would be the opportunity to get an impossible.